Hello everyone and welcome to PC Retro Tech. You remember in the previous video I've been working with these SuperSocket 7 motherboards. This one here has a VIA MVP3 chipset. It's a Lucky Star motherboard, and in this system here we have an ALI chipset. It's a Gigabyte board, and you remember that I actually repaired this board in the previous video, so if you want to check that out, there's a link above. Now what we found is that this board supported the AMD K62, and I have one running at 500 megahertz in it, and that made this system massively faster than this. But the real head scratcher, and the thing that I spent a lot of time trying to figure out, is why this board was faster than the VIA board with a Pentium 233 MMX, which both boards support. And as you'd have it, 5 minutes after I uploaded the video, a viewer already spotted immediately what I was doing wrong. There's actually a BIOS option in this board which I hadn't set, which should make a big difference. So what I'm going to do first of all today is to switch that on and see whether this board is indeed faster. Well, these are the chipset features for the VIA board, and what I did in the previous video is I went down this list here and set SDRAM to 8 nanoseconds in the bank that we're using. I set the cycle length to 2, I went and set the cache timing to fastest here, and just generally checked that all the other cache options were enabled. But I totally overlooked this final option here, the AGP 2x mode. And this was a real facepalm moment. This is the sort of mistake that I was making very early on when I first started the channel. Of course we have an AGP 2x video card. It's an Asus V7700 card with a TNT2 GTS chipset. So this will make a difference. So I'm going to enable this and we'll rerun the benchmarks and see whether this board catches up. Well, this is not at all the expected result. I mean, this is actually a 4x AGP card, so it really should have no problem with that 2x AGP setting. But as you can see, we're getting all sorts of colors and weird artifacts here. Now this is probably a driver issue. Of course, Windows is perfectly happy at the moment and Device Manager says everything is installed correctly. I'll first of all reinstall the VIA 4-in-1 drivers, since that's the most likely problem. And a viewer actually pointed out that in some of the VIA 4-in-1 drivers at least, the VIA GART driver can be problematic. That was more in regard to performance than issues like what we're seeing here, but I'll look into that as well to see whether there's a standalone GART driver that I can use with this board. Before I reinstall the drivers, I decided to go and turn that AGP 2x option back off again and see whether everything goes back to normal, and indeed it does. Now it could still be a driver issue, so I am going to turn it back on now and try to reinstall the drivers to see whether that does fix the problem. Well, I found a solution to the problem. When you install the VIA 4-in-1 drivers, there are actually two options here, the standard mode and turbo mode. Now I tried installing with turbo mode again just to see whether reinstalling the driver helped, and that made no difference. But when I install in standard mode, then everything is fine. So have it working, let's try and do the benchmarks and see whether anything's changed. Well, as you can see, we're getting 1391 3D marks in 3D Mark 99 now. This is a small uplift, but not very significant. We already had 1365 before with this board and that AGP 2x option off. But we're still well behind the ALI board where we had 1501 with the same CPU and other hardware. So I don't know whether that turbo mode being off is actually affecting us in a big way here. That's possible, I suppose. But what I'm going to do now is run the 3D Mark 2000 and 2001 benchmarks. There was a much bigger difference between the boards there, and I want to see whether we get the same small uplift or whether things are a little bit different. Well, again, in 3D Mark 2000, there's a very small uplift from 1155 to what we have now is 1200 3D marks, but still well short of the 1398 that we got with the ALI board. So a little bit of ground made up, but not very much. Well, there you have it, folks. 308 3D marks in 3D Mark 2001 versus the 284 that we had previously with this board with the AGP 2x option off. But still nowhere near the 390 3D marks that we get with the ALI board. That's almost a 25% difference between the two. So I'm beginning to believe this board is not particularly good, and I don't want to put too much more effort into it. There are other things I could try, such as the ViaGart driver. I could try a standalone one. I could put Windows 98 Second Edition. I could comb the BIOS and see whether there's anything else there that could improve this. But I feel that I put equal effort into these, and the Gigabyte board is really streets ahead. So I want to switch over to that now, and in fact I'm going to start overclocking the AMD K62 500 and see if we can push even more performance out of that Gigabyte board. And there's something interesting that I've noticed in the Gigabyte manual. Under the expansion slot section there, you'll see that it says one AGP slot supporting 66/133 MHz speed. And this is intriguing because you'd normally expect the AGP video card to be running at 66 MHz or twice the old PCI at 33. So 133 would certainly be a big jump. But I did find a Vogon's forum post saying you can overclock AGP slots. It's just unfortunately not particularly reliable. You have to luck into a video card that just happens to work at that speed. Now the frontside bus in this board will go all the way up to 140 MHz in increments, and the AMD K62 500 that we have in it has a frontside bus of 100, so we've got plenty of room to increase that. And some viewers have said that the video card that I chose here, it's a little bit later than the board itself. It's about a year later, and would probably be bottlenecked by the CPU. But I chose that video card deliberately because I wanted to have an experiment where I could increase the speed of the CPU and see how much of a performance uplift you'd actually get. But then I want to go a little bit further again and put in some later video cards and see what would happen if a user just kept upgrading their video cards over the years. For how long could they keep this SuperSocket 7 motherboard going? Now on this motherboard, a viewer noticed that I hadn't turned on data merge, which apparently should give us a little bit of a performance boost, so I'm going to switch that on. And of course we have an AMD K6, so I'm going to switch on write allocate, which it certainly has. The spread spectrum option here apparently is just for conformance to some FCC regulation. By spreading the frequency out over a broader range, you get less power at a given frequency and therefore less radio frequency interference according to the FCC. And so this is really not relevant. It should be off if you want the greatest stability. I'm not sure that it has exactly the same meaning on a modern motherboard, so just be careful about that. Look that up before you go switching it off on your modern PC. But yeah, this is all we need to do, and I'm going to rerun the benchmarks just to get a baseline at 500 MHz before we go on with any overclocking and see if any of these options have made any difference. Well, I have to say that made more difference than I thought it would. We had 3660 previously with this CPU, and it's now up to 3850, which is a noticeable improvement. So I'm going to quickly run through all the other benchmarks and get a baseline now that we have everything performing a little bit more optimally. Well, maybe I was jumping ahead of myself there. So in 3D Mark 2000 we get 3260, but we had 3284 before. So maybe the highest score that we got in 99 was just a fluke. Sometimes there's some variability in these benchmarks. I'll try 3D Mark 2001 just to be sure, but probably the speed hasn't really changed. And that is just about exactly what we had before. We had 1101 previously with this CPU, so it looks like there's not really any performance change with those BIOS settings. I don't know why 3D Mark 99 is faster by about 5%. It's probably just down to timing variation. I will quickly run through the DOS benchmarks and confirm that there's exactly the same thing there. But let's move on now with our overclocking. Well, the first thing that I've done is increase the frontside bus speed to 105, and that gives me a processor clock of apparently 523. And it seems to be booting okay, so we're going to try it out at this speed. I don't want to go up too much in one go. I want to monitor the temperatures of the power delivery of the graphics card and the CPU just to make sure we're not pushing it too hard. Well, that is unfortunate. As you can see, it's already hung, and this is 3D Mark 2000. I'm still at the 105 megahertz frontside bus overclock, so we didn't get very far at all. But not all is lost. First of all, I don't feel any real overheating happening here. All the temperatures feel about the same. I mean, certainly the voltage regulator on the main board, you're going to take your finger off after 3 seconds, believe me, but this is pretty normal. So I think probably the graphics card is likely to blame here, but in order to confirm this, what I'm going to do is lower the frontside bus and raise the multiplier instead. So I'll still get similar CPU frequency, but it won't be pushing the AGP slot as hard, and we'll see whether we can get better performance that way. Well, it does seem to actually post, so we're going to go through with this and see whether we get anywhere with the benchmarks at 550. Well, the 3 benchmarks went through no problems at all at 550 megahertz, so that totally rules out that the CPU core could be the issue. It could still be the CPU, just not the core. So I'll give you a comparison between the stock 500 megahertz figures and what we have now. So in 3D Mark 99, we've gone from 3850 to 4074. In 3D Mark 2000, we went from 3260 to 3446. And from 3D Mark 2001, we went from 1104 to 1151, as you can see on the screen right now. So in order to go any further, we're really going to have to get that front side bus speed up. Obviously we can't go any higher on the multiplier since we're at the maximum 5.5 that this board supports. So there's 3 things I'm going to look at. The first is, do I have a PC133 memory stick in it, or have I accidentally put a 100 in? Secondly, I'll look at the BIOS options for the memory and cache and maybe drop them back a little bit and see if I can get the machine stable at that higher frontside bus frequency. And if that fails, I have another V7700 card. Those who watched the previous video will know I have 2 of these. The other one doesn't have a fan, but I can switch the fan over onto that card, and perhaps that card will just be more stable at the higher frequency. Well, I've made some progress, so I did actually manage to get it to run through all the tests at 105 megahertz frontside bus by dropping the speed of the RAM. So I went from high to normal RAM's timings, and then I also increased the cache latency from 2 back up to 3 again, because I noticed that the RAM itself is only rated for cache latency 3. So that did get through, but unfortunately the scores are just a little bit below what we already got at 550 megahertz. So I decided to increase the frontside bus again to 110. So we'd still be at 550 megahertz, but using the frontside bus instead of the multiplier to get there. And unfortunately, as you can see, it's hung in 3D Mark 2001. So it got almost all the way through all the tests and then stopped. So the only thing I can think to try now is to set the multiplier back to 5.5 at 105 frontside bus and see whether it will even boot at that speed. Well, I haven't really got very far with the machine at 575. In fact, as you can see, it seems to think it's running at 600. And that happens whether or not I use a frontside bus of 105 with a multiplier of 5.5, or a frontside bus of 115 and a multiplier of 5, both of which should give me 575, not 600. Now the machine will boot at the moment, and I've just fiddled with BIOS options. I also tried switching over the graphics card, and it does seem a little bit more stable, perhaps with the other GeForce 2 GTS card. But so far I can get it to boot, but not all the way through all of the tests. Well, it's the next day now, and I had a bunch of time overnight to try a whole load of different combinations, and I've actually had some success, including some new high scores. So what I wanted to do, of course, was to try a later video card, but in order to do that I needed to use a different driver. So I don't have any GeForce 3s, I only have a bunch of GeForce 4s, and the driver version 8.05 that I was using just doesn't support those. But as I went through the other driver versions, I had to unzip the files, and I noticed that they were always corrupted. And I realized, of course, this was the CPU, having problems with the unzipping process. Now, I anticipated that, Certainly if you get games and benchmarks like this running, it's not necessarily pushing the CPU as hard as something CPU intensive like unzipping a file. I did realize though that if I concentrated on trying to get the zip files to work, then maybe I would get the whole system stable. And this paid off. So of course zip files don't use a graphics card, so I only had to focus on the CPU and RAM. So I went through a bunch of sticks of PC133 RAM, no difference, and then I could focus directly on the CPU. Now the only thing I could think of to do there, apart from check that the cooling was okay, was to increase the voltage a little more. And I checked online and found that people were using insanely high voltages, which I wouldn't recommend for overclocking their CPUs. So I decided to try 2.2, as mine is pretty cool at 2.1. And what I discovered is that immediately the zip files were going through without any problems at all. I mean, there were consistent problems before I did this. That meant that I had a much more stable system, and lo and behold, the benchmarks almost went all the way through with that setting. Now I tried a slightly higher voltage, didn't have any luck getting further stability, but what I decided to do in the end is change from a frontside bus of 115 back to 105 and set the multiplier to 5.5 instead, which this CPU seems to be able to handle more easily. And then everything was stable, so I got all the way through all the benchmarks, and I now have new high scores. So in 3D Mark 99, I now have 4179. In 3D Mark 2000, 3471. And in 3D Mark 2001, 1170. And all of those are about 7% or so higher than where we started at the stock frequency of 500 megahertz. And they are a little bit higher than the highest we've had so far with any other settings, maybe about 100 points higher. So what I want to do now is try a frontside bus of 110 and see if we can get the CPU up to 600, which apparently most of these should work at, although I'm dubious as to what voltage you have to use to get there. So the other thing I want to do, of course, is try and find a driver version which works with the GeForce 4s. Now what I noticed is that if I go to 53.04, the GeForce 4s work, but the performance is terrible. If I go back to the original GeForce 2 GTS card, the performance is 2/3 what I had before. So obviously I can't use these later drivers, so I have to find a driver somewhere in between which supports Windows 98, not most of them don't, they just seem to be corrupted, that supports the GeForce 4, and which has good performance. So that's where I'm headed, and if I can do that, then I think I can get an even better score out of this machine. Well, as you can see, I got some new high scores here, but this isn't from running the machine at 600 megahertz. In fact, I had no luck with that whatsoever. Windows wouldn't even boot. Now I did try increasing the voltage just a little bit further. I went in increments all the way up to 2.5 volts, which is as far as I'm comfortable going. I don't think it'll damage the CPU for very short runs like I was doing, but I had no luck at all. Windows wouldn't boot under any circumstances. So what I did instead is find a stick of RAM that was much happier with CAS latency 2 and the fast DRAM timings. So I changed those BIOS options, and now I have scores that are significantly better. So in 3D Mark 99 we're up to 4244 now. In 3D Mark 2000, 3578, and as you can see in 3D Mark 2001 we're up to 1225. And all of those scores are almost exactly 10% faster than the stock scores that we had at 500 megahertz. But you've got to ask yourself the question, is it worth overclocking your CPU and running it out of spec in terms of the voltage just to get an extra 10%? And my personal view is that you might notice 15% if it were sort of a subconscious kind of thing. It just seems zippier. 20% I think is the point at which you start to really be able to say, yeah, for sure, that's faster. 10% I'm not so sure. So for me personally, I don't think the overclocking is worth it in this case. Maybe if I had a CPU that went all the way to 600 megahertz comfortably, then it would be a different story. But I'm not huge on overclocking anyway. A lot of other people do it much more than I do. I do it every now and again for entertainment purposes only. So this machine will probably go back to the stock 500, or maybe I'll stick with 550. Either way, I think it's time that we moved on from trying to speed the CPU up and see what we can get out of the graphics cards. Well, it looks like I'm going to have to give up on giving a meaningful comparison between the GeForce 2s and GeForce 4s on this system. The problem is that I can't find a driver that supports the GeForce 4s and yet gives good performance for the GeForce 2s. I mean, the main issue is that my GeForce 4 4200 Ti, for example, requires at least driver version 29.42, and this is the terrible score that you get with that driver with the old GeForce 2 GTS card. We had 4179 with the old driver, the 8.05 driver, and now it's down to 3496. Now, before you jump to any conclusions about what NVIDIA might have been doing here, something nefarious perhaps to make their cards look better, it's more likely that they actually just had more CPU intensive drivers later on because they could. Later on, systems were faster, they had Pentium 3s and the like, and the speeds were really going up. So if you had a faster system, you could afford to have a more CPU intensive driver, and this would actually be an advantage or a benefit. So I will check this out, but I think what's going to happen here is that even the GeForce 4s are going to give a low 3D Mark 99 score on this system. And I might get a higher score for 2000 and 2001 because those rely on 3D features being available on the card for their score, whereas 99 is really just relying on the sheer performance. I mean, all the tests run in that case, so you're really comparing the performance of the cards in terms of pixel pushing power. So I'll do the comparisons and I'll put the scores up, but I'm not expecting those to be very meaningful on this system. And I think this is what we're basically learning here, is that this system is crippling for later video cards. Well, this is the GeForce 4 4200 Ti running the lobby scene in 3D Mark 2001. And you can still see quite a lot of jerking in this. We haven't made it playable. The car chase scene is even worse. It's still around 2 or 3 frames a second, which is an improvement, but not very much. So just putting a later video card in doesn't solve the problem. We're still bottlenecked by the fact that we only have 2 times AGP support. We have fairly low frontside bus compared to what they got up to later on, and also bottlenecked by the CPU itself. There's really not much you can do to get decent performance out of this system. About the only benefits are that demos and games like this that use features that weren't available on GeForce 2 actually run, and you can see that this is going through here, whereas it wouldn't be without GeForce 2 GTS. Well, this score looks quite promising, 2786 versus the 1225 that we had before with the GeForce 2. But it's mainly only because the tests all ran, whereas they didn't with the GeForce 2. If you go back to 3D Mark 2000, we only get a score of 2566, which is way below the 3578 that we had with the GeForce 2. And 99 is even worse. We got a score of 3528 with the GeForce 4 versus the 4244 that we had with the GeForce 2. So I think this underscores an important point, that just putting in a later video card in isn't going to speed the machine up. All that it's going to do is provide features that weren't there before. Now obviously on a later system with a much faster CPU, it's a different story entirely. But the object of what we're doing today was to see whether just putting in later video cards would keep this system going for some years. And already by the time we get to video cards from 2003, things are completely lost. So yeah, definitely this was a very interesting test, And I feel like I've learned a heap doing this, but it's a little disappointing that if you had one of these systems in the day, you pretty much had to shell out a bunch of new money to keep up. So that's basically all I have for this week. Unfortunately, time has run down again, but I hope you enjoyed this look at overclocking this AMD K62500 chip and looking at the various options in the BIOS and so on to make things faster. I think the overall thing we've learned is that you don't want to have a video card that's too late for the system because the drivers will slow it down, and that overclocking isn't necessarily worth it unless you can get a really significant improvement in performance. The Celerons certainly overclocked very well and it was worth it there, but here I'm not so sure. Anyway, I hope you've enjoyed this video, and if you did, give it a like and subscribe, and we'll see you in a later video. Bye.